Right.
Yes, that's coming through.
Brilliant. Okay. Right, Mark, if you just say next, I'll hit the button.
Perfect. Okay. Well, thanks everybody. Thanks, Gillian, again, and the Digital Surge team for giving me the opportunity to talk to you all today about some practical implementations of robotics and how they can really transform the manufacturing space. Talk about some of the key drivers for automation and hopefully some of the key learnings that we've learned. As Gillian alluded to, my name is Mark Higgins. I'm the Director of Operations here at Fast Technologies. So I think, Gillian, can we go to the next slide, please? So just to give you a bit of background, I know Gillian did give an introduction. Is that automation?
I am sorry.
You scroll up. Up.
I'm going the wrong way.
You're going the wrong direction. Yeah, yeah. Wrong direction. Yeah. So,
is that the end or is that the beginning?
No, that's at the start there. So go back to that slide, please. Yeah. And there should be a play button on this. And again, it's just a short infographic. There's the play button. And it just gives a bit of information. Oh, yeah. It may not be running correctly here over the web. But Fast Technology has been going now for 20 years now. And over that time, we have been automating in both the physical and in the digital worlds for our customers. And our unique offering, because we can deal with both the automation of hardware and automation of your processes, we can also augment that with the automating your data acquisitions by connecting to devices. We can analyze the data automatically, and some of our software techniques that we've been deploying with our customer base allow us to provide then workflow automation at the back end. And that allows you to really automate your full manual process from the hardware through into the software space. And our principle behind that is really that we can automate so you can then focus on your core business and what really makes you money. So if we go to the next slide. So before really diving into some case studies, I just wanted to set the scene for everybody and try and pose a couple of questions to get people thinking and stimulate some debate internally. So robots have been around, for almost 60 years, it's 1960s, but then all of a sudden over the last 12, 18 months, people are really starting to talk about them at the levels in which is very encouraging for us as an automation company. But they're really wondering now, how can they use robotics and automation to transform their lives? So the question really is around, well, why is that? What's driving that conversation? Why are people getting so excited about robotics now? There's probably a couple of drivers and a couple of key themes that are doing this, in my opinion. And probably the first one I would suggest is that robotics and industrial robotics in particular, they're getting cheaper. If we look back, over the 25, 30 years and beyond, the cost of robots have been decreasing. Now, I know this chart predicts prices to go down to quite low values by 2025. I don't believe that they'll go that low, but certainly they are coming into the area where they're becoming amenable to SMEs. So 25 years ago, you could expect to pay around £100,000 for a robot, but this has fallen to levels now that SMEs, for example, can see a return on investment. And whilst 25, 30 years ago and over that period of time, the larger multinationals who are running, maybe 24/7 operations could install a robotic or automated system, and they can see that payback happen over a multi-shift approach. SMEs running single shifts were probably struggling in terms of the viability and the return on investment that they would see. I think then you couple that with the introduction of Cobotics and the ease of implementation and the programming that they can bring. It really starts to demystify robotics for many people and removing any perceived barrier of entry. But I don't think that's the real driver. It's certainly one of the background influencers. I think, Gillian, if you go to the next slide, please. I don't think it's a real driver, and there's something else playing into it. And I suppose if we look back over the last 3, 4, 5 years, we've seen some significant changes and a series of paradigm shifts in terms of things that have been happening that has really driven a demand for automation. I think firstly, if we look back at Brexit and the contraction of the labour pool, and then we move on post-Brexit, we move into a pandemic that affected the global supply chain and everyone across our world. And that's changed then and shifted attitudes to work and how we work. And then now this year, we've been faced with geopolitical instability that has been really destabilizing the global market. I think these things, coupled with then a productivity gap that we're starting to talk about, has really accelerated our thought process around robots and automation. So I believe that these factors are probably the bigger drivers in terms of the decision and the reason people are talking about robots and cobots. Again, talking about some of the numbers, and so it's quite alarming whenever we look at the UK as a whole, and we say that the UK ranks 5th in the G7 for productivity. So we're sitting way behind, some of the more established economies in the G7. And then if we look at Northern Ireland as an entity and as a region, we actually sit 20% behind the UK average. So whilst we're looking at the UK sitting 5th, so I just see a question there: who is 1st to 4th? So we obviously have the US, we have Germany, we have France and Italy, who would be the countries there we're competing with. And that gives you an idea of your marketplace. So if we're local manufacturers here, if we're competing against people in GB, for example, then we're already 20% behind the productivity levels that they're at. But if we're competing with companies further afield in those other economies, we definitely are far behind, and we really have a task at hand. Now, the good thing is it's, everybody talks about robots and cobots and automation as the savior. And globally, sales are increasing. There's 3.5 million robots in industry across the globe. On average, that's increasing at around 7% year on year. So it's showing great growth for robotics. But then whenever we look at some of the numbers for the UK, they don't go with that trend, and we actually see now in 2021 there's been a 7% decline in robot sales, which puts us at a robot density of about 101 robots per 10,000 workers. And when we look at density for robotics in the workplace, that sits us 24th for robot density. And for anybody who wants to know where that would leave us, that leaves us out in the far regions where we're looking at this competing around the same levels as the old Eastern European blocs and emerging countries and economies, far away from where we need to be. So I think these are the main drivers why people are really starting to talk about robotics and cobots and automation in general. It's number one, the cost is decreasing, but primarily it's the productivity gap and the need to close that productivity gap with robotics and automation. I think it really for companies in NI, not to be alarming, that where we are with our productivity and where we are with the level of automation, it becomes more of a fundamental sustainability issue for manufacturing here in NI. So, and those companies who don't engage and start moving on their journey, I think that they will soon be left far behind. And the sustainability piece I'm talking about is not an environmental side, it's more on the fundamental sustainability of the company. We would see if we leave in another 3 to 5 years, that gap will just extend, which will mean that people will become less and less productive and will be forced with challenges that they probably can't survive. Next slide, please, Gillian.
just see another, I'm honestly, I'm hard scared to touch anything on the screen apart from moving your slides, but I can see there's another chat. I just see another notification. Is there somebody else
Okay.
another question or anything?
Does anybody want to ask a question there that's relevant or to the slides there?
You can shout out. No, okay. I just, in case I'm missing something on the chat,
Okay.
I really am scared to do anything too ambitious here. All right. Sorry.
Okay, thanks. So then the question is, what can we do? A lot of that was bad news there and setting scenes, etc. But the good news is there's things we can do. There's solutions that we can deploy, and we know these, and we've been doing these over the 20 plus years that we've been in business and in operation. And I suppose today I've got a couple of case studies that hopefully will give you an idea of some simple robotics and simple automation, and then how we can move that into very complex automation and robotics, and show you a flavor of how we can help transform your operations. Again, the nature of our customer base means it's very difficult for us to be able to share case studies live in an event like this. A lot of our customers require us to sign NDAs and keep their information very confidential, because that's obviously giving them a competitive advantage. So apologies, I can only share a couple of things, and even some of the pictures I struggle with sharing some certain images. So, but the first case study is with a company called Husqvarna, and they are an outdoor equipment manufacturer, and they have a location in the northeast of England. And this one's on robots making robots. So if we just want to go to the next slide, please, Gillian. So I'm pretty sure everybody has seen these funky, cool-looking robotic lawnmowers on TV. The adverts are out there over the summer periods. Some people may actually have one, but these are really cool pieces of kit, and they were made by hand in the northeast of England up until a point where we got engaged with the customer. And the reason for, or the challenges they had, was that their manufacturing was very seasonal. They knew that if they didn't have all their equipment on the shelves by sort of midsummer, then they weren't going to need to be making any more, and there was no more need. They weren't going to sell anymore. So their distributors had to be well stocked before that. Therefore, it meant that in August, stroke into September, they were able to shut down the production and then focus on maintenance and improvement activities on the site. But the challenge that they had with that was, because the manufacturing is seasonal, they only needed the operations team and the production teams for around 10 months of a year. So the company flexed each year by adding people as they needed to manage their production demands. But as we know, things were changing, and whilst 5-10 years ago that was okay in the local area, they were able to get the 2,000 people that they needed to fulfill the 1,200 roles that they had. They started to get less and less applicants each year, and they could predict the trend was going to be to a point where they weren't going to be able to fulfill all of the positions that they had. And then they had that on top of all the usual manufacturing pressures that everybody faces, the cost of poor quality, the safety and ergonomic issues, the productivity constraints that we've talked about, legacy hardware and controls, and all those things added more and more reasons to why they needed to move. Finally, and it was something that I wasn't quite aware of, but they had a stigma again of selling robots that were assembled by hand on an old production line. They said that the large distribution companies, their customers who would come to their site as they were launching a new automower, they would come and they would show them in their demo room this nice fancy new robotic mower, and do the presentations, and everything was very glossy and very, very modern looking. But whenever the guys then went onto the factory floor, not to say they were embarrassed, but they looked at it and said, is this really the right approach we want to be taking our customers onto a floor and seeing old equipment manufacturing these state-of-the-art robotic lawnmowers? So that was a significant driver behind their need to change as well. Next slide, please, Gillian. again, hopefully we can see something here through the images, but due to the sensitivity of some of the products, I'm not allowed to show any of the product being made, so which is why I can only take small snapshots of the production line, but hopefully it gives you a flavor of what we did. But through the conversations that we had with their engineering team and what we were trying to do, we developed a modular approach for this customer. Each module could be designed as having a fully automated cell, a semi-automated cell, or a fully manual cell. And what we mean by that there is the production cell concept was a 3-meter section that could be easily removed and replaced depending on where they were at with their automation journey. And that automation journey could be a fully automated robotic cell with some screwdriving activities that we have on this production line. Or it could have been a semi-automated cell where there's a bit of automation in one half, and then the other half has got a person that's performing the production process, or then a process where it was fully manual still, then allowed fully manual activities. We also had a vertical racetrack here, which opened up access to the rear of the line and allowed replenishment and future automation and fulfillment. So it was a neat solution. It was a lower footprint solution. But again, it served a lot of the needs for the customer. It was a pallet-based high precision conveyance system that was really the foundation for this. And again, this is some of the challenges that many manufacturing teams face whenever they're trying to automate their processes. If you can imagine trying to assemble a robotic lawnmower, there's a lot of cables that need to be put in place. There's a lot of screws that need to be put in place. There's components that need to be put in place. And for that to be moved into automation, you need to have a foundation where you can accurately position the substrate or the base that you're actually fixing to. So the conveyance system provided us the position accuracy that we needed to have to install the robotic automation. Things where the joystick, which controls the direction for the wheels, the wheel motor fitting assemblies, so they were actually put in place and then screwed in place, and again fitting the top chassis onto the base chassis and screwing those into place. On the bottom right, you see a 10-stage rotary test bench, and that was designed and built here. Again, their test benches had been off the production line, and it didn't lead to a nice linear flow, and it was very labor intensive. For every test bench, for every function that needed to be carried out, they needed a person at that. And we developed a 10-stage one where the operator would lift the assembly whenever it was finished, put it onto this test bench, and we performed the offline test functions such as the software download, the keypad test, which is why you see the small yellow robot there. It's a FANUC robot in this particular case because that was the customer standard. And there was the brake tests and tilt tests to make sure that it could sense if it was falling off, say, the edge of the garden. So all these tests were done on an automated test bench. And again, that not only saved in labor, but it also saved in the takt time and was able to produce at the takt time that was needed for the production line. And then finally, we automated the packaging line with case erectors and case sealers and a robotic palletizer, making the overall line much more efficient and needing less people. So I think if we go to the next slide, please. But that's just, again, a bigger picture of that rotary test bench. Again, nothing much more to see in that. I'll probably go to the next slide. So on the left here, we can see the output here, which is the pallet of robotic lawnmowers as they coming off, packaged, ready to be put into the distribution center. See some numbers there, but again, it wasn't all plain sailing. We had significant challenges around products. So if you can imagine, all the product development up to the point that we started to intercept with the company was been designed for manual process and therefore hadn't been designed for automation. and fixing this wasn't changed overnight. There was a process here, an evolutionary process, where they decided that legacy products, for example, wouldn't get any upgrades, but all the newer products would get features that allowed automation to be layered in. And that's why we went back, when we go back to the modular approach, allowing automation, the modules to be removed and new ones slotted in and changed in format, allowed them a very flexible approach so they could dial in more automation in the future. But typical examples of what they had, if you're putting a wheel motor onto a plastic housing, there's no lead-in features that allow us to locate correctly and hold it in place, so we could then insert the screws. Some of the screw points were down deep wells that a person can navigate through, but it becomes much harder for a robot to do. And again, with very poor access to that point. So through the journey of working with the customer, we were able to then recommend features going forward that could be put into the newer models that allowed better automation going forward. But the benefits in terms of what they got out of it were quite significant and very clear. And I think the biggest one was, again, a 10% increase in product throughput. So the line that we put in, they were able to reduce their takt time from 54 seconds down to 48 seconds. And whilst that may not sound a lot, it actually equates over the course of a day is to an extra 120 units for that line. And if you multiply that across then multiple lines, you can quite see that the significant increase in terms of throughput per day from that one site. There was 100% traceability within the manufacturing process because of the automation, because we could see and we could record the torque values for the automatic screwdrivers. We could see the process being carried out at each individual step, and there was a full digital thread that was being pulled through the manufacturing steps. We reduced the overall headcount by almost 15%. And again, this project led to future automation projects within that company. And we now have 6 of the 7 lines having the rotary testers that we saw. 5 lines having the automated packaging. We're actually doing the 6th line now. The guys were over installing it last week and this week. And then there's 3 lines have been fully converted to the new modular design to allow the automation and enable the automation with future automation planned next year. So from this customer, I know this customer is quite a large customer, but this customer on their journey, they saw automation and robotics as pivotal for the success of their site in the Northeast. If we can go on to the next slide, please, Gillian. So the next slide is a complete end of the scale in terms of the application and the technology stack used. And this case study is with a customer called DuPont at their Kevlar plant. And it was for autonomous machine tending using a fully mobile robotic solution. Next slide, please, Gillian. So Kevlar, as many of you who know, is one of the strongest man-made fibers. Which is why it's used in bulletproof vests and security and armor, tire manufacturing, protective clothing, and applications like that. So all of a sudden you can see the challenges you're presented with whenever you've got high-speed rotating equipment. Spinning this type of yarn or fiber onto a cardboard core, as we can see in the picture. And the team at Kevlar had a need to identify a solution to the age-old problem they had of people working with high-speed rotating equipment. So I'll give you an example. The previous slide there where you saw the machine face, there's 12 to 14 cores on that machine face that people need to lift off whenever it's completed and it's built to size. That's in an offline position. Meanwhile, there's an online position which is rotating at a high speed, and obviously you've got the Kevlar yarn that's being spun onto that. So there's significant hazards with that type of operation, and the guys at Kevlar had been looking for a solution, and many of those solutions being put forward were, put a linear axis, a 7th axis with a robot on it in front of that bank of what they call winders, front of the machine. But again, a lot of those issues, or a lot of those solutions, had issues with them in terms of whenever people needed to access the actual machine to do something to either the yarn or to fix a problem or to change a piece of equipment, they couldn't get access to that because of some other automation sitting in front, and removing that automation took a long time. So it didn't really work for them, some of the previous solutions. So we put forward then a fully flexible self-driving robot that could machine tend as a potential solution, and we've been working on it then for a period of time. The solution needed to be safe, but it also needed to be scalable across, not only multi-machines, multi-sites and multi-geographies. And whilst this particular project was being done here at the site in Maydown in Northern Ireland, the real benefit for them was whenever they went to some of the larger plants across the US and further afield. If we go to the next slide, please, Gillian. So here you can see what our solution was, and it was to develop the first collaborative self-driving machine tending robot. So again, I always tell our customers we have a toolbox of ready-to-go technologies. And what we did for this particular application is we went into that toolbox and we took key components that we knew worked, that were industry ready, and we pulled them all together into an integrated solution. So this is built on a mere 200 platform. So that's an autonomous mobile robot. We then have a UR16 6-axis collaborative robot, and we use the 16 because basically the payload that some of these bobbins are weights up to 12 kilograms, for example. So we needed something with that level of capacity. We used an RG6 end effector from OnRobot, and we highly customized it for what we needed. And we also then used a 3D vision system. And as you can see, there's no airlines on this particular robot, so there's no attachment to anything else. It's fully self-driving and self-contained and powered within itself. So we put all these together and put them into a shell that you can see here, and deployed it onto the site. Now, this particular robot uses the natural geography of the manufacturing floor and validates it against its onboard map, and then allows it to be fully integrated then into the factory control layer and other business systems over Wi-Fi. So we're not connected to any Ethernet sockets. We're not connected to any power outlets. We're not connected to any airlines. It's fully autonomous and mobile, and connecting to everything over Wi-Fi. And that allows us then to handshake with the actual machines on the factory floor, the machine controllers, and pass product information to the robot that allows it to perform the functions that the people perform. Now, we did have challenges, and some of those challenges were around the integration with the factory control network, and how we managed to pass all this information across the machine layer, from the machine layer across Wi-Fi into the factory control network. There were challenges in this, but again, our team was able to overcome it because we know so much about software inside that the physical space as well. Next slide, please. So again, some of the numbers behind this particular application, again, so in our mind, it was the first of its kind. So it's completely powered by DC power. So there's a battery inside the MU unit that then provides that DC power into the universal robot. So we're not converting DC into AC to power a robot. It's a fully DC system that I think we got the first one from Universal Robots at that time. And it's the one was being powered then also with the 3D vision control, which is fully integrated onto the end of the robot arm. The fully collaborative robot arm uses then the laser functions on the mobile platform to allow it to adjust sensitivity to surrounding area, and again to people. And that's done dynamically. So as people come into the area, we can reduce then the speed of the robot and make it much more collaborative. And as people remove themselves from the area, it can go back to its full speed. And again, that was one of the main reasons why DuPont liked it, is because of the safety features of it. We housed a lot of the main controls of the unit here on the back panel that you can see. So a lot of those buttons allow us to replace the need for actually a teach pendant, which again was another reason why people didn't like these types of systems on the floors. With teach pendants can get broken and then you can't operate the actual machine. So we did a lot of that there offline and put that onto the shell. And again, because it was fully integrated into the factory control logic, allowed us to scale this particular solution into a fleet of up to 100 units. So now we're at the stage where we're looking at further implementation across the factory floor and then across to different sites. We have this here, again, safety standard approved, again with TUV. So again, another major factor for this particular customer. Next slide. I think that's, in terms of the case studies, that's pretty much everything. I suppose then the question is, how can we help? And maybe if you just go to the next slide, everyone will be glad to know this is the final slide. So again, from our perspective as experts in this field, we understand the journey that you face and a lot of manufacturing teams face. It's quite daunting. People don't quite know how to start, but we're here. We can help you navigate your way on your journey in a way that suits your business. You know, starting from defining the strategy and the vision for where you want to be and what your future state of your operations needs to look like, and setting out your key objectives. We can help with that. We can help build and train your team, because your team needs to be able to understand and speak the language of automation. It needs to understand the technology and manage the flow of information to coordinate any project. And if you don't have somebody that can do that, then quite often that can lead to misconceptions and people not understanding what they're getting. But we can help, again, build and train the team so they understand what it is they're getting and how best to interact with it. Identifying a project is critical. And if this is your first step, which I think is part of the straw poll at the start, a lot of people are just thinking about it. If this is your first step, then you don't go for the holy grail. You don't go for boiling the ocean. It's the quick wins that you really need to be looking for, because quick wins build confidence. And if it's your first one, you really want to build confidence very, very quickly. Get everybody excited within your environment that automation is the way forward. And then that way you can build that confidence levels up and stay focused on achievable goals. Finally, we would say you need to talk to experts. Make sure you're on the right lines before you start buying equipment. So many times we walk factory floors, and probably a lot of the other contributors will have the same opinion. We walk the factory floors and we see a robot that was maybe purchased because somebody had got some spare capital monies that they could set aside. And the robot's sitting in the corner and doesn't do anything. And whenever we ask about that, we had some money, so we bought a robot. We thought we would buy one, but we didn't have a project for it. And then slowly but surely, then it just fails because they didn't have a clear strategy, and they didn't know what they were doing. And then that can quite often then taint the approach that people take to automation and robotics, and people become become more reluctant and less open to going further into that space and automating their factory floors. So we would always recommend talking to the experts, and there are lots of experts out here, and we're here to help. And again, don't worry if we get involved in this. We're here, we can help, and we can help educate, we can help define strategies and identify projects. I think that's everything, Gillian. I hope that was useful for people. Again, it's such a short period of time. I could probably talk for a bit longer, but if anybody's got any more or questions or things like that, then of course feel free to reach out and we can talk about it.
No, Mark, that was brilliant. Has anyone any questions for Mark? I'm trying to just see. Rebecca, do you implement your own software solutions or recommend third-party commercial products like Siemens, MindSphere, or Fanuc Field?
So we have a selection. So we've got a very high-powered software solution that we work with one of our partners. It's an American partner called Symphony AI, and that's for some of our semiconductor and pharmaceutical and medical customers. And it allows them to do a lot of that workflow orchestration that we talked about. We also have simple visualization and MES tools that we use. For example, in food and beverage, we've got a company called Appian, and they have a factory MES software that if you need an MES and need to talk to the machine layer, then we can help implement that. But we also build some of our own solutions. And those really depend on the application that we're working on. It can be something built on the .NET platform, or we can build it through a different variety of technologies. So I suppose to answer the question is it depends on the application.
And funny, Rebecca's just asked as well, and I was going to ask this as well. Are there any open source products?
In terms of software that can be used and platforms that can be used, there are open source. Again, it all depends on the wherewithal you have within your own company to sustain any software solution that you put in. Bear in mind, everything in terms of automation, robotics, software, all of those things require some form of sustaining post-implementation and making sure that you've got the team there that can do that, or else you have to then sub that out to companies like ourselves, for example. And that's not really something that we do a lot of because we're more focused on the implementation side.
Yeah. And are you finding now that the more of the maybe Rebecca might have to take over here because I'm really bad at asking these sort of questions. So the systems that you're trying to integrate to, do you find more of them, one that factories or production facilities already have, are more open source or have APIs now that makes all this sort of integration easier? Or
again, it depends. Sometimes
open.
Yeah, so sometimes we go into manufacturing sites and they've got old technology there, and we'll piggyback off that, and we'll create our own signals that we can bring into the software environment. And sometimes we've got systems that have APIs that we can just dial straight onto as well, and use that programming interface that we can then pass information through. And then other stuff you can use third party. So if we're using something like OPC, then we use at times the Kepware solutions for connectivity through to, for example, some PLC applications or PLC hardware. We would use something like OPC and communicate over OPC UA.
Great. Oh, thank you. I one sort of, maybe not a question, more an observation. Sometimes when people see, there's one of your slides about the lawnmowers was saying about the reduction in headcount, and some people might be like, oh, this is awful, that sort of thing when the machines are going to take all our jobs. But this company couldn't, you were saying they've noticed this downward pattern of being able to get the staff, the people on the production line. And also a lot of these jobs are repetitive or dull, or just you can use staff in a better way or upskill them then on the technology. So it's not, I think that's really important point.
Exactly that.
Robotics.
I think there was a survey done in Denmark, and again, Denmark is a leading economy for collaborative robotics in Europe. And I think there was a study done in Denmark in which they looked at the companies who automated through robotics and cobotics. I think it was a 10% increase in headcount through that introduction. And the reason for that, I believe, is that as we become more productive and more repetitive, then we become more profitable, we can sell more because we have more capacity, and then we end up in recruiting then higher paid jobs, and that contributes more to the economy and more to individuals. And a lot of things, you walk factory floors and you'll see somebody at the end of a production line lifting boxes and putting them onto a pallet. That's not what people were supposed to do, and I use the old one, the old analogy of farming, for example. 100 years ago or 200 years ago, people were plowing fields, stand behind a horse and a plough, and all of a sudden the tractor came on, and the farmers loved it. I don't think that, but that was automation. Again, it was a system or a device or a piece of equipment that was going to make life easier. And certainly it's the same, I think it's the same argument that can be made now. There's lots of jobs that people were doing that people aren't best served at, and we're not geared up for doing those, and those highly repetitive tasks. It's not something we should be doing, and I would suggest that we should be doing higher level tasks and higher grade work, and obviously higher paid work.
Yeah, no, absolutely. Has anyone any other questions for Mark? You can put them in the chat, or just feel free to unmute yourself. I think you can.
Apologies, as usual, I've overrun.
Well, don't worry. Well, I think there was a lot of my fault at the beginning. Look, well, Mark, thank you very much. If you're allowed to certainly send me, any contact details or high level slides. But if you can share that slide deck, I know there were some pictures of client sites in it or whatever. But if you can share what you can, I can send it on to everybody. That would be great and super. Well, if we break now for our cup of tea, if we come back at 10:45, does that suit everyone okay? Oh, I think Rebecca's just asked, do you find barriers to the integration of legacy software where the clients would like or need to upgrade at times? If I send that on to you, Mark, and you can maybe pick it up with Rebecca.
Sure, yeah, of course. And if anybody's got any other questions, feel free to reach out, and hopefully I'll give what I can back. May not be able to answer everything.
Brilliant. Look, thank you very much, Mark. I know you have to shoot off to help one of your clients, but super. Okay, everyone, I'll see you back in 15 minutes. Zoom recording. Thank you, host. So welcome back, everyone. And next up we have Alan from NRC. And Alan, if you were on at the very beginning when I introduced you, when I was reading out your biography, and I said that you'd worked with caterpillars rather than worked for Caterpillar, but I think everyone sort of
all right, I missed that.
Maybe you did. Okay. Yes, I can see your screen. Okay.
Okay. That's the full screen now, hopefully, yeah.
Yeah, look, perfect. I'll go on mute now.
Okay. I'll try to keep moving along because I know we're behind time a wee bit. My name is Alan Reid. I'm an innovation manager for Northern Regional College. So I look after a team of innovation technical specialists that go out to different companies and mentor through their projects and help to upskill them as best they can, and also work on the likes of innovation vouchers and basically anything where we can support industry and have the connection and make those connections. And say it's funded also by a connected program, which we'll talk about a wee bit later on. So my background really in robotics is I started my career about 28 years ago with a subsidiary company called Mapro, part of Parscreen. And then I was there about a week and they asked me if I was interested in supporting their robotic welding system that they just bought. So that was my first introduction into the robotics. I was working on that for a few years. Got that up and running, welding chassis for the telescopic handlers. I then moved to FG Wilson's. It was now then turned over to Caterpillar and introduced them to robotic welding as well, and designed and installed and programmed, trained up and all the rest for about 6 systems in there as well. Moved on to electronic industry. So again, high speed robotics, again, away from the welding side of it. And then for the last 14 years, I've been with the college in NRC here in Ballymena. And NRC had made a conscious decision that they were involved in robotics before I arrived here, and we were training industry in the different systems. So we don't train just using the toys, as you can see in front of us, but we have the industrial robots. So we have 4 ABBs on site here. The one on the right-hand side is probably here about the longest, about 18 years. It's about 20 kg payload. The one in front, in the foreground there is 168 kg payload, and the one on the left is 10 kg payload. Our 4th ABB, then we installed that in front of a 60-ton press brake. So you can see it's all in behind the guards, quite a large area taken up, but it's a fully automated system, and we're one of the first organizations to have a robot in front of a press brake. And a couple of companies have taken this up and have put in systems of their own in regards that we can't find automatic fold machines that are able to cover the range from very small parts right up to large parts. And they found that a robot in front of a press brake was an ideal solution. And if anybody's operated press brakes in the past, they know it is a dull, repetitive type task. We also have on the college here an IGM welding robot, where we've been doing training for different companies on that. So it's a nice wee system. Again, ties in well with my skill set and my previous experience in that. Recently then we have bought, we've got 3 FANUC robots. They're in nice wee training cells like you see here. And we had these for the World Skills. So we had 2 guys, Cameron Middleton and Adam Kirkpatrick. They represented the UK. So they're first in the UK, and they went to the World Heats then a few months back, and did very well. We're also one of the first organizations to have collaborative robots when they first came out. So these universal robots, probably about 7 or 8 years ago, we got a UR5 at the time, and it was thought it was great as a training tool. It's an industrial type robot, and it certainly it can withstand the day-to-day pattern it can get within an industry. But what we found then was that being in a training organization, a collaborative type robot, people kind of looked at it as a more of a training tool than an actual piece of equipment they can use within their own organizations. So we set about making projects or doing projects that would prove that their flexibility and their capabilities as well. But we grew it over a number of years. So I went from UR5 and now our 6 UR10s across the different campuses, because we find they are quite adaptable. They are easy to maneuver around to train up the different students, and even transportable into the different classrooms. Different systems then, we may not have the robot systems here, but we do support it, and we support industry within these different manufacturers' robots. So the likes of the KUKA, the Klus that make welding robots again, ABB obviously, the Universal, the IGM then, because we have the Kawasaki, we got upskilled in, and have done a lot of work for industry as well on it. And then more recently the FANUC. And I think we have also Yaskawa there is missing from the list as well. A couple of examples of the industrial support. I was through a shared lecture scheme. I spent 4 years with Ryobi, 2 days a week, looking at their maintenance department and doing some of the robotics training. But we also got upskilled in their Kawasaki. So they moved away from ABBs into Kawasaki into one area of their factory. One of the main issues in the Kawasaki's was that the programs couldn't be modified, couldn't be edited. And the beauty about robotics by definition is there's something that's reprogrammable, but they couldn't modify the steps because of the way it was tied in. So I had to strip out the program, take out all the offsets as such, and made it that they could easily identify the target points and tweak them if need be. One of the other issues they had is that an odd time the shop blaster would move the component as it was going through the process. So when it came to picking the part out of the shop blaster, when it's moved, the robot would crash into it. And these being a very strong robot, would actually bend the frame that the part was in. So we looked at the crash detection system within the robot system. So it's something that's there, just the manufacturers actually charge you to trigger it on or switch it on. So we're able to get the code, switch it on, and then put into the program the parameters that was required for any time it came into collision. Since that collision, then back off a couple of mil, and since then they haven't damaged any more parts or any of the equipment. The project on the right-hand side is for a company, SRCL, and they collect all the sharp boxes from the medical industry, from the different hospitals and health centres, and that's all over UK and Ireland. So this company, we went down to Dublin, and they had no Kawasaki support in Ireland, and the Kawasaki UK recommended to come up to ourselves. So we looked at the program, we went down, we did the maintenance on the robot, we updated the program so they could once again tweak the steps, tweak the points, and we then modified the program, taking out a lot of the dwells and a lot of the inefficient areas or wasted time, and we're able to get the efficiencies way up within that. We also did it we recommended them to go across to Leeds. So we did a few visits to Leeds, and over the weekend, we took the program, modified it offline, did the training, put the program back in again with all the wasted time out of it and all the dwells and breaks that was in it. And we were able within 2-3 days, we had the team trained, the program modified, the system maintained, and it was running then at 30% more efficiency, which meant the whole plant was actually 30% more efficient, which meant they could go from 3 shifts to 2 shifts just in time to take on the Scottish order, which was a great success for something that really only took 4 days. Other areas, again, I spent 1 day a week for a year with Terex in the bottom left. And again, they knew how to program the system, but they wanted to adapt it to other components. And I go to a lot of different companies where they're able to run the program, but the biggest issue is how to apply it, the application of it, and how to present the parts to it for welding. And the same mistakes keep cropping up. So it's nice to be involved, and we come up with different designs and different ways of presenting the parts to the robot welder. The project then on the top right was something we got into is cycle testing. So this is called like a squirm and Herman test. So the heavy robot that can lift 168 kilograms, we had 85 kilograms in a casting, and it was able to come down onto the aircraft seat and move in sort of a predetermined path, sort of like 18 cycles a minute, where the robot on the right hand side was able to swivel the chair sort of backwards and forwards as a 13 cycles a minute, which meant that we weren't drawing a figure of 8, it was totally random. And this was to detect whether the cloth was able to withstand the wear and tear of people sitting on it. And during that cycle, or during that test, we'll probably go through about 3 pairs of denim jeans, and usually the seat came out pretty okay. This is something they use, I think, in the car industry as well, exact same test. That led to other cycle testing, and when we got collaborative robots, we then did a small cycle testing on the likes of the pouch holders and stuff like that. And we got our first UR5 that we mentioned we got. We had that, and we were able to run different cycle tests. We upgraded them to UR10, did more cycle tests, and that company then now has 7 URs doing all different cycle tests to prove back to their customers that the product design is up to scratch. There's many different types of collaborative robots out there. There's probably 50 plus different companies that manufacture different versions of collaborative robots. A lot has come up with this 2-arm scenario, but you find more and more that they come back to the traditional 6-axis robot on the top left-hand side. So what makes a collaborative robot collaborative? So it's about juiced or involved by 2 or more parties working together. So we have a nice wee 2-arm robot here, Japanese robot making a typical Japanese dish, like it's a ikonomaki, they call it, sort of the poor man's pizza in Japan. And why automate? Automation is options for business. It's not really an option, so it's a necessity. So we find more and more that we're going to have to move forward with automation. We're going to have to involve robotics, as Mark highlighted earlier on, is that we're way behind the game in this as a country. There's the countries that are moving forward with this, especially when it comes to the collaborative robots, is India and China. They are buying way above more than any other country. And you think that they have the cheaper labor, they would have a harder business case to justify, but they're moving forward with it. They see the advantages. And a lot of countries, it's not about, do we use robots or do we not use robots? It's about how many robots do we use. So businesses that choose to automate experience faster growth, increased productivity and happier workforce. And any business can benefit usually from some form of automation. And the collaborative robot brings in another dynamic of that, where in the past it's been very much, it was the big players, the high automation or the high volume businesses that would like to use the industrial robots. That was caged, that the product came to them. But with the collaborative robot, that's opened it up for the smaller companies, SMEs, just to have more of like an assistance to a task, to assist the person that's there, or just to do small, simple operations. So it's simple to implement and use as a collaborative robot. So when you buy or you install a system like an industrial robot size, like the ABBs or the Phonics or Kukas, you normally have to go for a 4 or 5 day training course. And then you have to be familiar with your turnkey system once the integrator has installed it. And then it runs for a while, and then after a while you have to maybe change it over onto another product, and you have to learn it all over again. Comes to collaborative robots, you tend to get the robot arm in one box and the controller in another box and a manual. And you say, there you go. You should be able to go through the tutorials and basically get out of the box, install it yourself, create a small program and have it moving about. And usually within like 2 or 3 hours, somebody with very little or no experience in robotics can have this up and running because it's that intuitive. Big advantage then is it's cage free. So it can be a lot of expense by putting guarding around any particular type of production. It could be 10 grand upwards. So that there's cost savings there. Space saving as well, because you don't have to cage it off. Same as the way as we have the robot in front of the press brake. We're able to redo that project and actually put a collaborative robot in front of that and a wee video later on to show you. So space reduction is good. Engineering costs, we don't need to have maybe dedicated robot engineers. This can be taken on by, the operator in some cases can program a lot of these systems. Flexibility, so it's adaptive, it's reconfigurable. And again, we said about it being intuitive and very portable. So one of the projects show later is to show how adaptive it can be. And you can take literally a collaborative robot and have it running one particular task on a Monday, and you can move it to another task on a Tuesday. It doesn't have to be run that task 24/7. It can be changed over, and relatively simple too. One of the issues or barriers to taking on robots is the acceptance of it. So there's a misconception, and I've had this in the different companies that have been involved installing robots, is that, oh, you're taking jobs away. That's going to do more harm than good. And after installing the robot and it running for a while, the same people coming back saying, we need that robot running, need it going, and become very dependent on it and think it's a great job, like a complete conversion on it. And any company that I've been in, it's strange in regards that when you do your business case for it, that you do talk about how many jobs it's going to save, how many jobs, instead of having 3 or 4 people do that job and put a robot in, and it'll do the same. But anywhere we've actually gone through the task or through the project to completion, I haven't seen anybody lose a job because of a robot coming in. We always see that the company grow and expand and be able to be more productive and more competitive. You could have unrealistic promises or expectations. That can be from, maybe from the sales side of it, that robots are going to do this, that, and the other. It's going to be the solution to all the problems. But those expectations is that, in some cases, you're going to have a robot welder, and somebody comes into the building with a part in the front of a forklift, and a scanner comes down and scans it. By the time it reaches the robot, it's programmed. It's not that case. There's quite a learning curve in some of these areas. You need to be some sort of familiarization with it, and that takes time and takes effort. Some of the safety requirements, how to ensure compliance to new and changing standards, or lack of understanding. So when collaborative robots came out first, a lot of discussions, a lot of arguments about what was really collaborative, what was safe. Is it finding a loophole in the safety regulations, or is it actually legit? And they've been about now, 8-10 years, and no real issues, and they were getting more and more popular as we go along. The payload might have limitations on it. Up until recently, sort of the payload's been 10 kg. But you are now at the UR16, and they've just released then a couple of months ago UR20. So it's 20. There's other manufacturers as well as 20 kg. So 20 kg is quite heavy when you go back to those ABBs I showed you. We have two ABBs at 10 kg payload and another one at 20 kg payload. So they are very strong and look a lot stronger or they're a lot stronger than what they look. Cost can be an issue as well, because as we know, with prices have come down in robotics, especially industrial robots, but the collaborative robots, they have creeped up a bit because of the demand. And again, you have to justify it. Perfect for dull, dirty, dangerous tasks. Certainly those are the ones that win. And a lot of industrial systems that goes in is set to task where you just wouldn't ask anybody to do it because the product's too hot or it's too heavy, or you need a high degree of accuracy. Collaborative applications looks at processes that tasks that are simple applications, highly manual, even a collaboration of similar sort of tasks. So if it's machine tending, that robot could attend several different machines using the same end effectors, maybe built on a mobile platform, same way as Mark showed with regards of the DuPont and the Kevlar. You could have that just on front of a lathe or mill, where it's able to take the part out, take it to quality control, and take it on to the next step of the process. Collaborative robots enables this partial automation opportunities, where it's in a lot of cases with industrial robots, because they're caged, because they're turnkey system, it's kind of an all or nothing scenario. You know, you automate everything or you don't automate at all. And where you can see, even with Mark's example, where it's quite modular, you could have an area attended by a collaborative type robot. And if that robot, for whatever reason, had a problem, somebody manual could come in and do that same task. Or you can add to it. So you can automate one part of the task and then move on and automate the next part of the task. You don't have to spend that 6 months to a year automating everything. Just do it step by step and keep adding to it. And you can put more workload onto that robot, and that robot gets up to its maximum. You can add another robot to it. So there's ways around it. So collaborative robots provide value and succeed when you have kind of 68 cycles per minute, because they are slightly slower than an industrial robot. You can take all the restrictions off them and have them go up to about 4 meters a second. When you consider an ABB does about 8 meters a second, it's still quite fast, but at 4 meters a second, it's not really collaborative, especially if it's the potential of sharing space with a human. But if it's behind something, they can get up to those sort of speeds. Low payload to 10 kg typical, so that's now increasing, so it can get up to 20 kg, so not so much a factor now. If you've got little robot experience, it's a great way to get into it. It's a great way to start and get those skills and experience with it. And my advice would be very much start at something that's very simple, something that's quite a repetitive type task that you want to get good payback on, but something you're going to learn from. And once you see the capabilities of it, then you move on to the next project. Low utilization can increase productivity within that machine. It also can run, this 24/7. So where maybe you have a process that can be run manually, but a robot may not be the same speeds or slightly less. You could have it that it runs day and night in the background. So processes previously seen as uneconomical or too complex, where partial automation might be feasible or desirable. So robotics, I was at a training course, and there's the guy beside me was from Nissan, and he says, why would they be interested in collaborative robots? Back then, wouldn't really consider them as a lot of dexterity with a robot, being able to do much in the way of car assembly. And they weren't strong enough to be able to hold a spot welder and do what you traditionally think of car assembly and manufacturing. But what they were looking at buying 1,000 of these. And the aim for that, the project they had in mind for them, was that the collaborative robot would be the bin pickers. So the person that has the dexterity and is able to do the assembling, they're allowed to get on with that and do that assembly. But as the cars will come down, different options and different colors, the robot arm is able to go and pick the next part and hand it to the person. So there was time saved by not having to go to the bins, read what it is that you have to pick out, find it, and then take it back to the station. So the utilization or the efficiency of the person doing the assembly was increased. And the fact that they're buying 1,000 of them, must have thought that was the way to go. Payback, UR can quote that we've got 195 days of payback on average. It really depends on the project. It depends if you're running 2 shifts, yeah, it's a bit of a no-brainer. You could get your payback sort of within the year. If you're on a single shift, then that becomes a bit longer, and the more equipment you put to it can also stretch that out. The first UR5 that we got here, we did the cycle testing on it, and we had a nominal charge on it in regards of the running cost of the robot, but within 3 months we had that robot paid back for, and we were able then to buy our UR10 from that. And it was just for the fact that it was able to run 24/7 doing the cycle testing. The 2 projects that we worked on, so once UR robots came into NRC, we work with the Connected funded program, and in part of that funded program, there's a competitive fund for projects where we can work with 3 or 4 companies, identify an area where we think we can improve things. And in this case, we wanted to take a collaborative robot and apply it to certain tasks. And we've got 4 different companies, 4 very different tasks, and set it up to show the capabilities and show the flexibility within the collaborative robots. So on the right-hand side, I'm going to show you a wee video clip, but there's 4 different applications. One was machine tending for a lathe. But a lot of that was focused in around the end effector to make sure that you can efficiently get into the machine, swap the billets over and get back out again. Then you can take your time when you're outside of that, because the cycle time's 5-6 minutes long. And in that time, you can then gather up the next part, do your quality checks or whatever it might be. And the robot then controls the door to the lathe using a regulated air cylinder, so that if anybody has a hand in there, it'll not have a pinch point. The other application was the operating the press brake as a collaborative robot. And the third one was cutting the foam. So the one that's in the picture there, the robot was able to pull the foam out to whatever predetermined length. So the operator could type in what length they want and how many they needed. It was able to lift the small tool, collect the foam, push it through the saw, switch on the saw, push it through the saw and back out again, and then set it into the right-hand side to be collected, or hand it over to the person that's actually assembling these onto what have been prams or pram handles. The one on the left-hand side then is for a tapping operation. So the robot is able, because it's got an adaptive gripper there, it's picking up the different tools that it needs, be it magnets, air guns, or in this case, there's a Tapmatic there as well. Or I think it's Mosquito Tapmatic. They can pick it up. It's got oil, tapping oil on the threader. It then is then set on top of the hole. Because the force sensors is in the individual axes, the robot just puts down a slight downward force, switches on the tapper in one direction, rotates it back after so many seconds, and then lifts it back up again. As long as the part can't rotate, then it'll thread okay. And then the parts are lifted and segregated out in the 2 different bins. So that's the 4 different projects. So hopefully this this video will run for me. So hopefully that came through okay for everybody. So that was just really to prove the concept and sort of to give ideas then to those companies to see how they can take that forward. One we did last year under the same funding, and again with 4 different companies that showed an interest or have robotic welding or would like to get into robotics to assist with the welding. So I had this idea of using UR, not as what some companies do in regards to think, oh, clever robot, let's make it become a welding robot and stick a welder on it. And they have companies have done that quite successfully, but it's for very simple parts. When it comes to the collaborative robot, we decided we'll use the collaborative robot as a positioner, a workpiece positioner, to be able to present the parts to a manual welder. A manual welder is about, on average, I think, 25% efficient when it comes to arc on time. A lot of time is spent taking the mask off, setting the gun down, picking up a part, rotating the part, assembling it. But if they had assistants inside the cell, so they can't have another person inside the cell, but they can have a collaborative robot inside the cell. And if it's able to pick up the part and present it to the person, they could weld it, hit a switch, and then flip over to the other side, hit it, and weld again, and then keep going around that way. Once we sort of started the project, we realized we can actually do one better in regards of the robot can, if we can hold the manual welding torch in a known location, the ER is able to pick the part up and actually present it to the torch at the right angle, at the right travel angle, right workpiece angle. And then when the trigger of the welding torch was pressed, after a light changes within the mask, the trigger comes on, the robot then knows to move, it moves at a set speed, and it's now able to put down a weld using a manual welding torch, but that looks something that a robot welded. It's that smooth, that's consistent of itself. And that increases efficiencies of the manual welder. So welding shops that maybe have 10 welders, they can add a few of these robots in, and next thing they've got greater capacity within that. And it's something that hasn't been done. It's not out there yet. And our biggest problem was for us was to make this end effector, and we had to make something out of brass. We had to design it, machine it up in house, using double grippers to make sure there's no slippage within the part when it's being held. And then we had to make sure it was earthed all the way back and the robot was fully insulated from what was going on. We also put magnets on it as well to be able to lift plates off a stack in the assembly operation. The other part of the project with this, when we had it designed and made, was that we could then integrate it into a robot welding cell. So as a collab robot is something that can come outside the cell because it can from a safety point of view. We could take parts in and assemble them in front of a welding robot. The welding robot comes down, tacks them, welds them up. The robot can then flip them over to the other side, welds them again, and then bring it back out again. So you don't actually have to stop what's going on inside the welding cell, because there's a lot of SMEs as small parts to weld, but jigging, fixtures, everything else is just too expensive, too time consuming to set up. And by the time they have the fixtures in place, that order might have gone, or it's not viable anymore. But for this here, we need very little tooling. The programming is relatively straightforward, and the flexibility is all there because you've now got a 6-axis positioner instead of just a single axis, maybe head and tail stock arrangement or a 2-axis orbital type positioner. So a wee video, show the video, and you see how it works. So again, say something hasn't been done before. Say a big part of that project was integrating the UR to the IGM welding robot, and having that handshake arrangement where one robot's looking for a signal from the other. We now have all those systems. We have the students that will go through the college. They will program those systems and get familiar with that, and they're able to do that within their level 2, level 3 programs. So moving on, is safety wise, Gillian, I was thinking due to time wise, maybe not go through the safety unless anybody really wants to, but like, you have the slides and you could share them with everybody. They could read through at a later stage, but it's just going through some of the regulations, safety standards. There's 2 or 3 standards there, but really what it boils down to when it comes to collaborative robots is that if you buy a collaborative robot and integrate it yourself, you have the risk assessment to do, and there's about 3 regulations there that you must consider. So the manufacturer is the top 2, the integrator is the bottom 3. If you buy a turnkey system, all these regulations are looked after. If you buy it yourself and install it, you have to do your risk assessment, make sure that it's still safe. The onus is on the company. So happy to take questions, Gillian, at this stage.
Great, Alan, thank you. Has anyone any questions there? You can put them in the chat or just unmute yourself. I know Mark was asking during the call your presentation there if this is going to be recorded. Yes, and I'll upload it. It might take me a wee while to download it and upload it again. There's I think a bit of editing to be done at the beginning. Squirm and Herman. I think that is my takeaway from today.
Squirm and Herman, yeah, very good.
You were saying as well about space. You don't need as much space if it's a collaborative robot, but it also can help companies save space as well, I guess, because you're maybe condensing stuff into one area for the cobot. You don't have to think about expanding footprint. It also can help you sort of optimize what you have as well.
Yeah, the press brake is a perfect example of that. Because the robot was in there. Normally press brakes are open on the shop floor. You can access them from all sides. That guardian has to go up just because we have the one robot in front of it. And then you have the complication of how do we feed this system? So we were just a training cell as such, so we carry the parts in, but the turnkey solutions has to have tracks, rails, light guard arrangements, a double light guard arrangement, make sure that nobody walks in along with the trolley, and then a way of feeding that back out again. That's where all the extra expense comes, and usually the robot itself becomes the least of all the expenses. You know, the conveyor systems and all that bespoke system is very, very expensive and very, very time consuming to make. So we just did the exact same thing, but we did it with a collaborative robot attached to that front rail. You can probably see the linear rail there with the front support arms. Attach it to that. So we're able to slide it to one side, use the press brake as normal, manually. And then when we wanted to use the ER, we slide it into position. And that could be anywhere along that track because the program's the same no matter where you're pressing something on the left-hand side or the right-hand side. And the controller just slots in behind the side of the machine, totally out of the way. And the UR, when it's not being used, curls up and it's at your knees, but it's not in the way. And everything else is open plan, open space. So it works out, it worked very well. So that's the comparison between the two. A much, much cheaper system, and it still works.
Yeah. Oh, brilliant. I think Mark Gray from Universal Robots was on at the beginning. He might have had to drop off. If you're still here, Mark, sure you can shout out. But Rebecca is asking, how have you found the KUKA software and integration? Have there been any robots you wouldn't recommend for newbies due to learning curve and barrier to integration? So it's in the chat there, Alan. There's maybe two questions there. How have you found
is that asking what my favorite robot is? Is it nearly? Well, I suppose as an organization, we obviously have different robots and stuff like that, but we don't, you know, we're quite impartial when it comes to it, and that's why a lot of companies come to us that are thinking about, you know, starting a journey in robotics, because we're not trying to sell them anything. We're impartial in regards of our advice. So we try to expand the different types of systems that we can work with, and depending on what's out there and depending on what companies are using, we get ourselves trained up with that, and that's usually done through the Connected program. It's very good in this way, and then go and give them the training courses, or be it through, you know, basic training, advanced training, or maintenance training, or even looking at different projects to modify it and tweak it. But we do get a lot of companies who would come to us saying, you know, we're thinking of robots, but I know if I start lifting the phone to different companies, I'm going to get inundated with calls, and they're going to start talking about a lot of technology I don't know much about. And we've done projects for companies where we've looked at their application and then went away and talked to 3 or 4 different suppliers and looked at what they're offering, what their solution was going to be, you know, what the floor layout was, and the flexibility in it, and what they're adding in on the price of it. Because there is quite a variation in costs. And a lot of times companies will obviously buy on cost, or they come across a second-hand robot. And there's an umpteen companies we could go to that's got second-hand robots, and they think they're buying a solution, but they're just buying a robot arm. Unless you know how to integrate them and take them right through the whole process, I wouldn't recommend it. So we do offer that sort of service.
Or any of the robots better for integration, and some you're like, oh, if somebody mentions the name, you're like, oh, this is going to be a nightmare. I know I'm probably putting you on the spot, but
there is. It depends how much you want to. The likes of that last project we looked at, the collaborative robots, UR robots, are all about giving that to the end user to integrate with, to add the inputs and outputs to it, and everything's nicely presented at the front of the control panel, with plugs that you can't interchange or anything like that. You can take those plugs out, move it to the next system, plug it back in again to their plugs, their inputs and outputs, bring up the installation file for it and the program, and away you go. And it could literally be a 5-10 minute operation. So they are designed and set up in a way that they could be really easily to integrate. The likes of IGM and Plus, they are dedicated robots to welding. So ABB, KUKA, I think they all do welding, but it's one of many applications that they do. So they have to modify their existing platform to become welding platforms, where the IGM includes, that's their business, but they don't like anybody integrating with it. They don't like external stuff. So when it comes to us integrating that UR to the IGM, we had to buy special cards for it. We had to upgrade the installation parameters and that installation file to accept that and have those predetermined signals that goes back to the UR. So a completely different kettle of fish to the UR. Because that's the nature of their business. They offer turnkey solutions to design around what your product is, come and install it, do the training, and then walk away from it. Where the UR is more about the end user doing it.
Okay, right. And interesting. So David Nickel is asking, was the UR IGM welding integration programmed offline or manually at the robot?
At the robot. We had, we did do a simulation and programmed offline as part of that project as well, which I didn't get to show you, where we have a cooker robot in front of a head and tail stock arrangement. So this is a joint project with the Queen's. The Queen's setup was that they had a cooker with a head and tail stock arrangement, and we put a UR in front of that, and that was to allow us to place parts on a drum. So it's very hard to jig and locate parts on a circular drum accurately. And if you didn't have these parts placed in the circular drum, when this drum was spinning, the balance would be way out. So it's difficult to jig, difficult to automate, but with this type of integration, we were able to do that. We weren't able to do a live model of it because that was all in the NRC, but we did do the offline programming and simulation for it, and for that aspect of it, for the fourth company that was involved in the project. So yes, it can be done, but I don't recommend buying robot systems and going straight to the offline programming option. Always get to know the robot, get to know its capabilities, and do it through the teach pen initially. It's only when maybe you're into your second shift and thinking of a third shift or thinking of another robot and you don't want to take it out of production that we might need to offline program it. The offline program we worked at with Caterpillar, and we've had some bad experiences, plus as a software package for offline programming for IGM back then was, that's back 20 odd years, and it was 22,000 then. So some of these things aren't cheap.
Okay, thank you. Any more questions for Alan? Okay. So Alan, I'll share your slides afterwards, and I think I have a copy of them already. And
should have, yeah.
Your contact address and stuff, but that was super. Thank you very much.
No problem. Thank you.
Brilliant. If we want to have another break for a cup of tea, and we'll come back at 11:45. Does that suit everyone okay? Or do you want to just take, I mean, it's up to you. Maybe just if we maybe take just 10 minutes to quickly come for break and cup of tea, and then come back at 11:40. Is that okay? So back at 11:40. Great. Alan, can you make me host again as well, please, just before you go? So if you go to over to my little screen, you can see the 3 buttons. Brilliant. Thank you. Okay, everybody, see you back in 10 minutes. And David, I will make you host. Is that okay?
Perfect, thank you.
Okay, so welcome along, David. That should be you now, so you should be able to share your screen. That's us, yeah.
Good stuff. You see it there all right now?
Perfect.
Spot on. Brilliant. All right, well, thanks very much, Gillian, for having us on board there now today and for putting this together. So my name's David Webb. As Gillian said, automation engineer with Reliance Automation. And just to give you a little bit of a background into Reliance. So Reliance as a company are almost 100 years old now at this point in time. Started trading bearings back out of the van of the original founder back in 1922, and they became a limited company then in 25. So we still have a large proportion of the business related to MRO equipment like motors, bearings, gearboxes, etc. But over time, that has kind of transitioned, given the fact that an awful lot of our customers are agricultural, industrial, and the kind of transition of technology, I suppose, kind of in and around the 50s to the 70s into linear technology and linear bearings and motors and drives, that side, and servos, and then through to robotics. We've been dealing in automation for probably about the last 30 years or so. We officially divisionalized the automation business there back in 2018, started 2019, to concentrate specifically on that element of the business, because it is quite a different, the customer base is very, very similar, but robotics and automation in terms of project business as opposed to set up of day-to-day spares is very, very different. So we have quite a novel business approach. So we are a technical distributor. Our job is to essentially find the best technologies around the world and make them available to personnel within the Irish market. So Reliance Automation, we don't specifically provide any integration services ourselves, and we provide the hardware for all the elements that go into a project, but we don't actually do the installation like the likes of FAST would do. So our business model is to partner with several of the integrator machine builders around Ireland, of which there's quite a number now at this stage. We probably have about 20 different partners scattered around Ireland that have various different specialities and are located in various different areas. So it means that for kind of somewhat simplistic automation processes, or for customers who have some automation experience in-house, we are able to work with you directly in terms of specifying equipment and helping you through the process of setting up an automation project. Or if it's a case where you would like to go along the lines of a turnkey solution, we essentially start off the same by specifying out the equipment and helping get the process set up in terms of the user requirement summary and different elements like that. But then at that point, we will bring in one of our partners to actually perform the installation design elements of that for the turnkey solution. So we're able to kind of address both sides. This is just a little snapshot of our automation hub that we've got in Dublin. So we moved to a new facility there at the very start of this year. So an awful lot of the technologies that I'll show you here now today, we actually have demo equipment for available. So personnel can bring in their parts, we can perform POCs and kind of talk about the various different options available for addressing different aspects and nut out some of the things that you may not see immediately when we start to talk about an application. An awful lot of the time what we find is, yes, we're moving something from A to B, but you don't consider all the hidden processes that the operators are doing during that. And it's only by actually walking through and actually taking it step by step to build up the process that you actually start to identify all these steps. And that's the key to a good automation project, is to have a well-defined manual process there beforehand. If it isn't defined very clearly at the start, you'll find that once the project goes along, the equipment doesn't necessarily do exactly what it is that you wanted it to do, purely because those specifications haven't been set out at the very start. So I've been kind of changing this presentation as we've gone along today, because Mark and Alan have kind of already addressed an awful lot of I suppose the benefits of collaborative robots over industrial robots and the different types of technologies there, and why the marketplace is moving out. So I've taken a few of those slides out. So what I'm going to kind of concentrate on today is trying to maybe introduce you to some other technologies and potentially some alternative ways of thinking to be able to address some of the applications that you have out there. For ourselves, we are seeing kind of the same trends that the guys have spoken of there now today. Most predominantly, regardless of what industry you're in at the moment, everybody is having an issue with labor, getting the right people in for the operations and having them available consistently. So a big portion of it is, especially at the moment, people moving towards lights out operation where possible, and how that can benefit the business in terms of having equipment available for you the next morning, or having essentially additional shifts to be able to fulfill the requirements that are in there. So in terms of our partners, we're partnered with several different manufacturers around the globe. So Universal Robots has been mentioned an awful lot today. So we're gold partners for UR. So we essentially represent them within the Irish market. But similarly, we're partnered with a number of different manufacturers across different robotics brands, different end effectors, vision systems, serialization, conveyance, all the different elements that are required to build up an automation project. And all the partners that we work with are either market leaders within their specific manufacturer, or they are niche technologies that have some very specific capabilities that help us to address things that aren't available from kind of your standard equipment. So we've talked an awful lot today about Universal Robots. I have to apologize. I've just gotten a new laptop, and an awful lot of the links that I have on this aren't pushed back to the videos. So I'll try and jump across to YouTube a couple of times. But in typical applications for the UR robots, or collaborative robots, we would see them, I'd say about 30% of applications that we do are palletizing applications. About 30% are probably machine tending in some way, shape, or fashion. Now that can be like typical machine tending in terms of like a CNC or a lathe, or it could be machine tending in terms of like lab equipment or testing equipment or something along those lines. And then the rest of the kind of 40% then is everything else. So from welding, sanding, polishing, screw driving, in vision inspection, several different applications out there. So touch on machine tending as a start. So we've talked about the robots that are readily available and easily programmable. The next steps, because this is such a common application within the marketplace, it's actually a relatively simplistic operation most of the time. Typically, you're picking up a test sample or a billet to be machined, presenting it to another piece of equipment, whether that be a welder or a lathe or a tester in some way, shape, or fashion, removing it once you've got the signal from your other piece of equipment that they have completed their task, and then placing it back within a fixturing. So given the fact that it's such a common and simplistic operation in general, there are quite an awful lot of pre-designed cells and setups that you can utilize for these. So a couple of the examples here. So Easy Robotics, they actually manufacture stands for the UR, which include fixturing and drawers, essentially. So to be able to allow personnel, once the robot is programmed, have sufficient feed there so that they can do a complete shift of operation. You could have, say, a couple of hundred different billets mounted within a drawer system, and then be able to run that lights out. Similarly, if it's a case that it's not an exact application and there is a little bit of customization required, we work with Ventian, who are a Canadian company. Now, Ventian manufacture their own profile, but they also provide a CAD package that allows you to design up utilizing their standard components. So they have over 1,000 different components that can be utilized to build up a cell. They also have pre-designed cells that you can mix and match and add different components to and cater towards your requirements, so that you can get something very specific for your application. They're very good in the fact that an awful lot of the way that we utilize them is we essentially draw a design on the back of a napkin, give them critical dimensions for the cell, and their engineers will then utilize their CAD package to create up a design. They can do this typically very quickly. Normally in about a day, we've got a cell design back. We normally have a design meeting then after that, or a half an hour or an hour to take off a few of the confirmations. And then normally a day or so after that, you have a completely designed cell that then can be shipped from standard components. Lead times are about a week or so in general. They've a new facility that's come over in Germany now to address the European market. And it means that all the components required to build this cell are available very, very quickly. It is self-assembly in that case, as opposed to a completely assembled unit. But another piece that an awful lot of the manufacturers are moving into is the software side of things. So Ventian and the likes of OnRobot and another few other companies, they're not too interested in what type of robot it is that is being utilized for the activity. The robot itself, typically you're talking about something with 6 axes. It's a means of moving from A to B. The softwares essentially allow you to program offline using agnostic models and then input that information into the robot in the forms of like a G code that the robot can understand regardless of the brand. And then you have your cell set up and your program done before you even install. Then it's just a case of hooking up the wires and then doing a little bit of calibration in there. So there's templates for the likes of machine tending, which essentially have all the logic built into it already, that can make the process very, very quick and simple to set up. So that's one thing I'd probably say at the moment, is that in the current climate with so many issues in supply chain, for complex pieces, like especially the likes of like PLCs and safety relays and things like that, that are on extremely long lead times, an awful lot of these elements are actually quite easily accessible. Like the likes of a UR robot we can have in about a month. Typical end effectors are about a week. The cell setup, again, probably about a week and a half or so. And with a couple of days training on collaborative robots, you can very, very quickly implement the more, I suppose, simplistic operations that are out there. So kind of to reiterate what Alan said before, and Mark, in that an awful lot of the time we go out to sites to perform audits for people to identify what applications they have within their processes that are automatable or economically automatable. And there may be one that is the highest ROI on site. It can provide massive paybacks over a kind of couple of year period. However, that project may not be the most simplistic one to implement. There may be significant design time in that, significant expense, additional training required, and a number of other elements that may make it that it can't actually physically be implemented for about a year. Meanwhile, there may be 2 or other applications around the place that could be up and running. They may not offer the same level of ROI, but they can be running in the same period that you are addressing this bigger project. So I encourage people to kind of consider the different paybacks and also the implementation time when looking at which projects it is that you're looking to take out there. Another very common application is palletizing. And again, there are a number of standard solutions for this that have been pre-designed out there. And similarly, an awful lot of these come with softwares that allow you to program your pallet patterns and things like that offline and then upload them to the robot. So especially if you're in a manufacturing facility that has an awful lot of different SKUs that are out there, and it's not economical to bring the robot offline while you're teaching in new configurations, there is software out there available to make these processes an awful lot easier. Most of the time it's just drag and drop once you have the initial setup, and we can perform simulations and things like that just to make sure that you have the correct reach on the equipment, and perform testing in terms of the grippers to make sure that you have the right amount of suction or right amount of grip for your specific product and payload. But again, all these kind of solutions are typically pre-designed already, so that they're very, very easy and quick to ship and distribute. And especially within the collaborative sphere, where there isn't typically as many additional kind of safety equipment required, or as much interface with external equipment as there is with industrial robots. And this can be a very, very quick and easy solution to implement. One thing we spoke about there today is in the collaborative sphere is typically kind of 20 kilograms is the highest payload that can be addressed by a collaborative robot. There is a solution out there by Cobotics, which they essentially utilize an external vacuum system similarly to a manual handling system. So the robot itself isn't actually taking the load of your item. The robot is purely there to perform the directional activities in terms of palletizing and depalletizing. Now I'm going to hop across here and hopefully, let me see. Just can't, sorry about this. It's just this tab is in the way. Yeah, there's one of them here. So you can see in these operations, so relatively large boxes or heavier pieces of equipment that require palletizing or depalletizing can be addressed within a collaborative sphere. So typically it would be a case that we would have had to install an industrial robot for this, and as the lads were stating, they take up an awful lot more floor space and guarding, and essentially. Whereas now there is the ability to be able to address this collaboratively. Now, what I would say is, because the payloads are so much higher, it does mean that the rates at which it can pick up are significantly slower. So you would be talking about kind of maximum power picks per minute, and probably more typically in and around 1 to 2, depending on the operation. But what we find is an awful lot of these activities, because of the weights that are being lifted, the process that they're being fed into typically doesn't keep up at very high rates. So normally it's like, I say, a bag of flour in a bakery or something like that. Normally they're only being lifted at a fairly slow rate anyway. So it means you're just able to address this collaboratively as well. So at Reliance, we are partners for several different brands of robots. In the collaborative sphere, we work with UR. We would view them as the best option for collaborative robots. Universal Robots essentially came up with the idea of collaborative robots there about kind of 10 years ago. And as a result, although there's been an awful lot of other manufacturers that have adopted collaborative robots in the meantime, UR, especially in terms of the interface and how easy they are to utilize, are probably 5 years ahead of most of the competition. And as a result, they have a huge amount of installations worldwide. They probably have about 60,000 plus now at this stage. So there's a huge amount of applications experience within the group that we're able to call upon for the various different activities. And they kind of build that into their UI in terms of providing palletizing software in there, providing force source work, providing conveyance and tracking software all out of the box, as opposed to them having to be external pieces. In saying that, not every application is applicable to a collaborative robot. We've touched upon the likes of payload so far. So it's, and yeah, typically kind of 20 kilograms max, up to maybe 45 in some circumstances. So in applications where a higher payload is required, an industrial robot is the only way to address it. The other side of things would be in terms of very quick cycle times. So normally with a collaborative application, we would be typically talking about kind of 6 to 8 picks per minute, depending on your cell, and potentially up to kind of 12 or 14 if it's all very compact, small movements. Whereas some operations out there require stuff to be done at almost 1 every second. Industrial robots are much more heavy duty units, and this is their specific design, is to be able to address these very, very quickly. So while they do tend to be more difficult to integrate with a higher level of expertise required, they do have a place within the market. So typically it is a case where when an industrial robot is required, that's normally when we will bring in the likes of FAST and other integrators, because they have the experience within their teams to know all the different elements and the programming capabilities. However, we do also work with some end users as well that want to spec up in terms of their experience with robots. In the industrial side, especially if it's part of an automation timeline, probably over the next kind of 5 years, where yes, maybe it may start off with your very first installation, very little of experience, and we can get other parties involved to kind of help through that initial setup. But as time goes and the amount of automation you have on site increases and the expertise increase on site, a lot of those activities can be taken on in terms of pre-programming and the rest. So Nachi are the industrial brand that we work with, and they are a Japanese manufacturer. They are partly owned by Toyota, which gives you an idea of the type of quality that these units are. Toyota are always sparking about their lean and the quality of their materials, and this is one of the robots of choice for them. You go into any of their facilities, they're Nachi and Yaskawa are the only two that they utilize. So while they don't have as big a name within the European market, they have a massive share of the Asian market and the American market as well, which are typically an awful lot larger in terms of robotics than Europe has been traditionally. They have an absolutely massive range. So we have everything from a little 1 kilogram robot all the way up to a couple of tons. And I suppose most importantly at the moment, we also have availability of most of the units up to about 160 kilograms. So in the supply chain issues at the moment, an awful lot of the manufacturers are 20 weeks plus for a new robot, whereas we have the ability to supply probably in a week to 2 weeks for the vast majority of applications that we come across. So again, just helping on that kind of implementation side and at the speed at which things can be introduced. Now, another unit, this is what we would call the niche and new side. So Wizo are a Swiss manufacturer, and they have only started actual production as of the start of this year. The unit has been in development now for a number of years and testing and the rest. So they've actually gone into full production now this year. And what this is the first sidebot. So this is a collaborative Delta picker or flex picker or spider. They go by a number of different names. So normally with collaborative robots, we have the issue, I said, of kind of relatively long cycle times. Whereas for small pieces, sometimes, especially say within the likes of the cosmetics industry, food industry, we're talking about an awful lot of small light products that need to be moved very, very quickly for kind of packaging and other activities. So these have the ability of moving up to about 90 picks per minute, but it being able to do it collaboratively. And this is achieved as they have built in they have built-in safety scanners into the base of the unit. The motors as well are monitored for their force sensing, and they have integrated vision systems built into the unit. So essentially you can load these onto a pallet truck and park them up beside a conveyor. And once you have your safety settings set up, they're able to work alongside humans. So it's a very novel piece of equipment. There's been a gap in between the kind of collaborative pace and the industrial pace without being able to set up massive safety fences and the rest around the industrial robots, whereas these have the ability to be able to work at that significant pace. And once an operator then walks into the environment, they then reduce that speed, and if contact is made, they completely stop and can restart automatically once personnel has left that area. Again, there's more and more applications out there that are becoming addressable now. So I suppose in general, what we would find is that there's probably applications that, say, 2 or 3 years ago, we wouldn't have been able to address these off the shelf. They would have required customized equipment and an awful lot of design time. But more and more is becoming the case where there's standard technology that's there, and it's a product. So as the guys have kind of touched on, we've talked about robots today, but robots are only part of the solution. So we provide an awful lot of the elements additional to that, so such as the softwares, the end effectors, conveyance, sensors, vision systems, all the other elements that make up a project. So in terms of end effectors, there's a huge amount now that are, again, kind of off the shelf available. If you had gone back a few years, typically there would have been an awful lot of kind of mechanical grippers, vacuum grippers, and that was probably about the extent of it. Whereas more and more so, we're seeing collaborative screw driving applications, collaborative weld heads, magnetic grippers, you name it. It's more and more selection that's out there. And an awful lot of the time, there's a huge amount of different manufacturers who can address the same project or the same application. So an awful lot of we do is advising on the different types that are out there available and which would be best for the product that you have and the activity that you have to address. As I said, we have an awful lot of these pieces of equipment available for demos and testings and POCs and things like that, just to give validation before you go off and purchase for your own application. Similarly, sometimes it's a case where the robots aren't mounted to a fixed position. So the case of machine tending, again, would probably be a very common application for this, whereby the cycle time of your equipment may be a couple of minutes and the robot's activity is purely maybe 10 or 15 seconds of that. So in order to increase the utilization of the unit, sometimes we'll put in a 7th axis to be able to move the robot from one machine to another, which it just increases the productivity of the machine. So these can be both vertical axis or horizontal axis as well. And again, there's a number of different manufacturers depending on the payload of the robot, the level of safety needed to be implemented, as in is it a collaborative track or not, is it an industrial cell? So lots of different elements, and as a result, there's lots of different suppliers that we work with because each one of them specializes within a given area. So far, we've talked about 6-axis robots an awful lot, but another area that is becoming more and more common is automated logistics. And similarly, there are essentially industrial and collaborative versions of the equipment that can be utilized within this. So AGVs, again, have been around for probably close to 20 years now at this point, automated guided vehicles. AMRs are more recent, probably in the last 6 or 7 years, which are essentially the kind of collaborative version of that. They have their own guidance system in there, so they're not constrained by having tracks on the floor or IR sensors that are built into the facility. And what this means is they're an awful lot more flexible in their implementation. So you don't have to worry as much about all the infrastructure that goes in and around it. And it makes them an awful lot more dynamic in that if an item is placed within the path, they're not constrained to wait until that item is moved by an operator before they can continue. They can reprogram a new path around the facility. And it also means that if your facility is changing in any way, so they're quite scalable in that they utilize their own scanners to map the area. And we'll hop into a quick little video to show you some of the different applications that are out there. So again, we work with MIR, which is Mobile Industrial Robots, and similarly, they've been around for a number of years. They're the market leader in mobile automation in terms of the AMR sphere. And similar to the UR, they manufacture the base unit. And what happens then is there's third-party manufacturers that create the top modules and the interface systems that go on there. So these can be the likes of roller modules, they can be the likes of hooks, they can be the likes of pallet lifts, even lock boxes and things like that. We find them used an awful lot within assembly, especially in kind of automotive, or actually even within hospitals is a big one as well. So any facility whereby you have a pallet truck operator moving from your production area to the warehouse, or where their real benefit is because of the size of the units, they're able to operate in and around the equipment. So it's not a case where you have to bring it off to a drop down area and then have an operator then bring it up to your workstation. They're able to work in and around the facilities, in and around the walkways, to be able to transport material to and from different locations. So typically what we will find is an awful lot of facilities look at the process of automation in terms of the final product, and that can be like the assembly or whatever it is that actually takes it in the build-up of that piece of equipment. And the logistics element is often kind of pushed to the end of the track, as in, look, we'll automate how we make the part first, and then we'll have a look at automation of transportation of it. But in a lot of facilities, what we found is that there's actually significantly more ROI to be achieved from taking the operators who are literally just moving stuff from A to B and placing them within the production line, or reskilling them in different aspects. Again, we're looking at activities that have absolutely no direct value add to the process, but are adding cost to it. So if we have a way of automating these, all the best. Yeah, similarly, I've touched upon all the different activities on there. You can even, as Mark showed earlier, place a UR on top of these mobile robots. So instead of constraining them by a 7th axis or a rail, they can be mounted on top of a unit and go from station to station. What was a big one during COVID, during the lockdowns, was also placing items such as UV cleansers on these and having them move around facilities. So essentially anything where you have an operator moving from one point to another point to perform an activity, we could look at for a potential application for these. Now, again, we've talked an awful lot about kind of robotics in general, but a large part of Reliance's business is actually in linear automation. So most typically, these would be the elements that we would provide to machine builders when making a bespoke piece of machinery. But every axis in there is essentially a 1-axis robot. So what we would look at is an awful lot of the applications that we would see. Sometimes they don't require a 6-axis robot. Your 6-axis robot is brilliant because it gives you your X, Y, Z trajectories, but it also gives your pitch roll yaw as well. So for things like welding and operations like that, where you need to be able to get in underneath the product, or where you need to be able to rotate something to go into a chuck of a CNC, absolutely brilliant. But there's an awful lot of applications out there that don't specifically require 6-axis. So we work with a number of different manufacturers. Again, we are Bosch Rexroth's partner in Ireland for linear drives and controls. And what Bosch have released there recently is a new controls platform called Control-X. So in the past, with an awful lot of these access machines, you had to have a huge amount of programming experience and knowledge to be able to set these up. Whereas what Bosch have done now is they've essentially created a core system whereby it's like the iPhone for automation. You can download apps onto this piece of equipment. So if you needed to be a motion controller for an XY system, you can download an app for that. If you needed to be a PLC, you can download an app for that. If you needed to be an IoT setup, so for communications and Industry 4.0 setup, you can download an app for that. But the other ingenious point of it is you're not constrained by the original software in that. So for a PLC, it would typically be the likes of Ladder Logic or something like that. You have the ability to be able to program this in whatever language it is you want. So you can program it in C++, you can program it in Python, you can program it in Java, whichever language it is that you have comfortable with can be utilized for this piece of equipment. So what we're finding is that there's, especially with the labor shortages around at the moment, there's, especially in the automation sphere, there's a huge demand on the amount of controls engineers and the rest that are out there. And as a result, there isn't a huge availability for them to be able to take on projects, whereby there is a huge amount of software engineers that have the ability to be able to program in these codes to get the machines to do the activities that it is that you're looking for. So what it's doing is it's essentially opening up the skill set that can be drawn into automation. They also have a number of kind of very simple predefined systems in terms of like presses, handling, dispensing, XY systems that come with their own browser-based interface, and simply all you're doing is programming them point by point with individual IOs. So some activities there, so like palletizing where there's no requirement for rotation of the parts in and around it, or dispensing and the likes of that, or even quality inspection, these can be addressed by simple access systems. Another manufacturer we work with is SMAC. SMAC are a American manufacturer. They're a spin-off from SMC, and one of the directors of that went in to specifically look at electronic actuation as opposed to pneumatic actuation. And SMAC are very, very niche in that they are very low force pieces of equipment. So not for very high loads or very high payloads, but where they specialize in is accuracy. So the encoders on these units can go down to 1/20th of a micron, and they can also run at up to about 20 hertz. So very, very fast, very, very precise operations. So what we find utilizing these for is measurement and inspection. So automated gauging of products once they have been manufactured, capping, also things like leak detection, whereby you can physically land the actuator on the outside of say a plastic bottle, a packet of crisps, drive into that at a known force, and if it is exceeding the amount of distance that has been pushed, you can detect whether there is a leak in your product or not, or any deformations on that. So again, sorry, I don't have the videos hooked up to this, but my kind of takeaway is an awful lot of the times that we look at automation projects, we're looking at like specifically performing tasks, okay, the likes of assembly, etc. Whereas an awful lot of the operator inputs are things like quality inspection and verification and things like that, that there's also tools that can be utilized to help automate those processes. In the ideal scenario, these will be implemented in line, but there's also a case for having these as kind of semi-assisted stations, whereby an operator is then just much more efficient at performing the task that they're doing, and therefore capacity can be increased because it literally just doesn't take them as long to use. Instead of using a manual calibration tool or a calipers to measure something, they can place the items underneath and get readings very quickly and verified back to a system that can be then put into the QA side of things. So there's not just elements within the production side that can be addressed. Another one that is becoming very, very common is pneumatic replacement. So especially at the moment, again, with energy costs as high as they are, pneumatics are very, very inefficient within a production process. Typically over 80% of the energy that is being utilized doesn't relate directly to the end movement of the actuator. This is from generating the air at your compressors, leaks within the line, various different elements. And we say that as pneumatics distributors as well. We are SMCs, tier 1 partners in Ireland, so we hold a huge amount of pneumatic stock. And we will also say that pneumatics are very inefficient. They have their benefits. Typically, the costs to pneumatics has been less than electronics, but we're getting again to a stage where it's becoming more and more comparable. So if we look at just a very simple actuator for a push on a reject line, a pneumatic setup on that might be a couple of €100 or so. Whereas in the past, an electric setup might have been closer to about 1,000. Whereas it's now getting to a stage where you're probably talking around kind of 400 or 500 for the equivalent electronic setup. And even though that still is probably about twice or 2.5 times the price, it has an awful lot of benefits in terms of the energy savings costs and also the maintenance costs. The electronics are typically essentially maintenance free, whereas the pneumatics, you have different elements like your reed switches, your relays, your lines, all other pieces that have to be regularly maintained. So when we're looking at the overall life cycle of the piece of equipment, typically the gains in the electric sides start to really kick in after about a year or two. And again, there's various different systems that are there for the likes of this. So here we have an example of a simple XY system. So again, for applications such as dispensing or something like quality inspection, what we've put on these in the past is vision cameras and had them running over a piece of equipment to pick up various defects and provide presence, absence and barcode reading and various different kind of inspection tasks. And a system like this may cost somewhere in the region of about 10,000 in comparison to 20 to 30,000 for a 6-axis robot. And that's robot alone without all the different elements that add on to that. So it's just to kind of open up to say that even within the robotic sphere, there's various different ways that different applications can be addressed. And that's a huge amount of what we do here at Reliance, is reviewing applications to advise upon the best or the most economic solution to a various task. So I'd encourage you to have a look at our website. On there, we've just got a list of all the different types of equipment that we've got available. We've also done a automation guide. Now, this is specifically towards the agricultural market. However, an awful lot of the guides and suggestions within that are applicable across various industries. Especially if it's a case whereby you are starting out in your automation journey and just need a little bit of assistance on where to go. There's an awful lot of points in there that will help out through the process, because actually identifying the application itself is only part of the battle, and putting it in and implementing it. There's an awful lot of things to be considered in terms of the skill level of personnel that are on site, and then the changes in and around the system that have to be implemented as well. So if we automate a very specific process, how does that affect things up and down line of that? How does that affect your ordering systems? How does that affect various other different elements within the process that also have to be thought about from an automation perspective? And it becomes part of the whole digitalization journey, as well as not just automation and robotics. One other thing I would like to share with you is we have been doing automation for a number of years now. And again, as I said, a lot of what we do is go out to sites, perform audits and advise upon different ways of addressing it. So what we've launched there now recently is a tenders portal. So if anybody has ever utilized the likes of e-tenders for government tenders, this is a privatized version of it. So essentially what you can do is upload your project requirements, and from that, it will pass out to the various different integrators within the field that you have specified. So again, as I said, there's a number of different integrators around Ireland. However, different ones have different specialities, obviously different geographical locations that they look after, and a number of other different elements. So I'll just play a quick clip just explaining this.
And there's no sound, David. Is that, do you need to unmute it or anything?
Good stuff. So, yeah, thanks very much for the time there. Sorry, I ran a little bit over there. But any questions or anything at this point?
There's one thing I think Emma mentioned before, that the website for Up Here's whatever it was, but it's not IE, it's .co.uk maybe. But I
Yes.
can send out the link. I'll check with them and send out the proper link for everyone for that. And I have put the feedback link as well in the chat there if you'll take 2 minutes. But David, thank you very much. And I think one of the big things I'm taking away from your presentation is ask the experts. Like, nobody knows their business like themselves, but if you're thinking about this, there's so many different things you could be doing, or so many different variables and whatever. You really need to speak to somebody here, you know, and get that advice and input at the beginning.
100%, yeah. And look, that's exactly what we're here for. I'd argue an awful lot we do is education of personnel in the marketplace. In Ireland as a whole, we are very, very far behind a number of other countries. When you have a look at the robotics side of things specifically, we don't even feature on the graphs. We're that far behind. Digitalization and the rest, yeah, a little bit further ahead. But considering there's so much manufacturing and the amount of manufacturing that it's a proportion of the GDP, we're very, very far behind. And as a result, there's not as much expertise within the marketplace. So there's an awful lot of work being done to upskill people coming out of colleges and people already in industry. But we've still got a long way to go. So don't feel any, never be afraid to ask for help, essentially, is what I'm saying.
Yeah, absolutely. And some of those companies like Mir and Nachi and Universal Robots and whatever, I'll share as well with everybody a link to our previous robotics webinar, because like Craig from Universal Robots came along and spoke, and Bosch Rexroth and different people. So there are they all did a presentation, so I can share that too with everybody as well. But thank you very much, David and Alan and Mark, and thank you all very much for coming. There's the webinar tomorrow as well on big data and AI next Wednesday too. So I put the links in those to register. But it's 12:30, so I'll let you all go. But I really appreciate you all coming, both to our presenters and to our audience. So any questions, let me know, and I can. But I'll share the recording when it's ready, and the slides and people's contact details too. So thank you all very much, and have a lovely afternoon.
Right, thank you.
Yep, thank you, Joe.